everyone, in this video I'd like to talk about the best, worst, and average case. So I'm referring to complexity, and sometimes we want to know about our algorithm. We want to know how fast or slow our code will run. And as an example, once I deployed a code that I thought was marvelous until I realized that I had such a large data set, my code wasn't going to finish running for about a year and a half. And that was definitely a lot longer than I desired. So I took my job down and rewrote my code. So I'm going to give you a very basic example here just so we can get introduced to these concepts. But in practice, you do want to have a sense of how complex, how fast or slow your algorithms are going to run. All right, so we are going to start off with n being an element of the set 5, 10, 12, 15, and 20. And our pseudocode that we're analyzing says while n is less than 12, do the following. N equals n plus 5. So what this means, it means the new value of n, so new n equals old n plus 5. It's a little bizarre because there's n's on both sides of that equation. That's why sometimes you'll see it written with an arrow, like we're sending the value of n plus 5. We're sending that to the new value of n. Anyways, this is what we're up to. We want to find the best, worst, and average case number of compares. And by that I mean this little inequality. How many times are we checking that inequality? So to figure this out, I'm going to make a table and I'm going to write the value of n in my first column. And then in the second column, I'm going to look at the number of compares. In other words, how many times did I check that little inequality? And that's how I'm going to measure, how bad or good this algorithm is. I'm going to measure the complexity of it by checking the number of inequalities that I'm doing. Anyways, the values of n that we could possibly have in this example are 5, 10, 12, 15, and 20. So I'm going to check what's going on for each of those values. So let's start when n equals 5. When n equals 5, I'm going to enter while n is less than 12. So I need to check if n, which is 5, is it less than 12? And yes, it is. So I'm going to hop in my loop and I'm going to set the new value of n equal to the old value, which is 5 plus 5. So my new value of n is going to be 10. Around we go again. We're going to check if 10 is less than 12, and it is. So now we've got n equals 10 plus 5, which is 15. And we're going to test one more time. We're going to check if 15 is less than 12, and the answer there is no, it's not, so we're going to stop. But the point is, we did do some checks. We did check 1, twice, 3 times. We checked 3 times that inequality. So I'm going to write a 3 down there for the number of compares. Now, when n equals 10, I'm going to check if 10 is less than 12. And that's true. So in we go. We're going to say n equals the old n, which is 10, plus 5 equals 15. All right. Now we're going to check again. Is 15 less than 12? No, it's not. So we're going to stop. Now we did do 2 comparisons. So I'm going to write down a 2. And now let's check when n is 12. I'm going to check if 12 is less than 12. And that's not true. So I don't even enter into that loop. I'm done. And I only had 1 compare in this case. And the same would be true if we ran through this for 15 and 20. Now, to answer the question here, the best case number of compares, if that's when our code runs really fast. So this is going to run fast when we only have to check things once. So our best case scenario is 1 compare. So recall they're asking how many compares, how many times do we check the inequality. Our best case is 1 compare. And that occurs when n equals 12, 15, and 20. Now the worst case is up here for 3. So the worst case is 3 compares. And then the average, we just have to do the average. So we've got 5 values here. We need to total them up and divide by 5. So I'm going to do 3 plus 2 plus 1 plus 1 plus 1, all divided by 5. That's going to give me 8 over 5, 8/5. That's going to give me a 1.6 number of compares. So that's on average what I expect, because I know the type of data I'm going to feed into this thing.